Hello, today I will talk about the greenhouse effect. And to start out with, we'll look a little bit at the composition of the atmosphere. And the reason I bring this up is that Earth's energy balance is set by the minor components of the gas in the atmosphere. So if we draw a pie chart, then the largest chunk of the components of the atmosphere is nitrogen, N2. That is about 78%. The next most important component is oxygen. Oxygen makes up about 20.9%. So between oxygen and nitrogen, you have 98.9% of all the gas in the atmosphere. And then the rest is composed of the minor components. And the most important one that we talk about typically is CO2. Now, CO2 only makes up 0.03% of the volume of the atmosphere. And then others like methane, nitrous oxide, CFC gases make up even less. And I should note that this is for a dry atmosphere. Obviously there's water vapor, so this is dry atmosphere. And then water vapor can make anything between 0 to 3%, depending on how wet it is. Now, the important point regarding greenhouse gases is that oxygen, O2, and nitrogen, N2, have no electrical dipole moment because they are so symmetric, and that means that they don't interact with the atmospheric radiation. So they're more or less invisible to the incoming and outgoing energy. The minor components, because of their more complex structure, do have oscillating dipole moments, which means that they can absorb and emit radiation. And those are, as a result, called the greenhouse gases, because they impact the energy balance of the atmosphere and of the Earth. The second point is that we learned in an earlier lecture that if you have no atmosphere, the surface temperature of the planet would be about 255 Kelvin. For pre-industrial greenhouse gas levels, the surface temperature was about 288 Kelvin. So 33 Kelvin warmer than if you had no atmosphere. And this warming due to the greenhouse gases in the atmosphere is what's known as the natural greenhouse gas effect. The third point I want to add here, number 3, is that CO2, methane, ozone concentrations are changing due to human activities. And so, for example, if we look at the Keeling curve, which measures CO2 in the atmosphere, we have found that pre-industrial CO2 was at about 280 parts per million. Now, it is about 410 parts per million. So an increase of almost 50%. And this will lead to higher temperatures, higher TS. In fact, predictions are that a doubling of CO2 corresponds to roughly a change in surface temperature of about 3 Kelvin.